Hello! Today we are going to thoroughly demonstrate and show you precisely how to effectively set the essential PID control parameters on the advanced IP5 drive system. PID control is a feedback-based system, and its main goal is to guide the system to a specific value, which we call the set point. So, what does PID control do? It compares the feedback value with our set point value. If the difference is 0, it doesn't react at all. But if there is a difference, it multiplies the difference by the 3 factors P, I, and D, performs a series of calculations and applies them to the motor so that the difference is quickly eliminated and reaches 0. To effectively activate PID control, we specifically need to accomplish 4 essential things. First, we need to activate the parameters related to PID control. Second, we need to specify the type of feedback we're using. Is it voltage, current, pulse, or something else? Third, we need to accurately enter the precise P, I, and D values into the drive, carefully based on the comprehensive calculations that we have meticulously performed and completed. And fourth, we need to set the upper and lower frequency limits. To activate the parameters related to PID control, we need to go to parameter OP02 and set OP02 to yes or activate it. To specify the type of feedback, we need to go to parameter OP06 and determine whether our feedback is voltage, pulse, or current type. Here, our feedback is of the voltage type. That's why we set it to V1. To accurately enter the P, I, and D parameters, we specifically need to navigate to OP11, OP12, and OP13. In OP11, we will then carefully enter the precise P value. In OP12, we carefully enter the I value, and in OP13, we then enter the D value, all based on the calculations we've performed for the project. To set the upper and lower frequency limits, we need to go to parameter OP14 and OP15. In OP14, the high limit, we set the upper frequency limit, and in OP15, the low limit, we set the lower frequency limit. Now my system is ready to be started in PID control mode. We want to use this module as our feedback. As soon as the pressure drops, the pump starts operating. Let me go into parameter DRV15 so I can show you both the set point value and the feedback value together. Here is our set point value and here is our feedback value. Let's test it one more time. As long as there is no difference, the pump remains off. As soon as the pressure drops and a difference appears between the set point and our feedback, the pump starts working. It compensates for the pressure. Until when? Until the difference between our set point and feedback returns to 0. Look, when I increase the pressure, my feedback value gets closer to my set point value. The pressure is compensated and the pump turns off.